Ray here from Action Pinball. Today I'm going to show you how to replace the onboard nickel cadmium battery on an old Bally motherboard with a remote mount battery holder that uses 3 common AA batteries. This is the board here to begin with. The old nickel cadmium battery mounted right across here in these 2 positions. It's been desoldered and removed from the board at this point. We're going to go ahead and show you how to put the battery holder kit together and how to connect it up to this board. Here's a triple AA battery holder that we're going to be using. This comes with 6-inch leads on it. I like to add some extension wires to these so that I can mount the holder off to the side of the motherboard or down on the bottom of the back box, wherever you think is most convenient. I've got a couple pieces of wire here that I've prepared, and I'm going to extend the wiring on this holder. First one, just basically I've stripped the leads back a little bit, about a ½ inch on each. Just kind of tie them together, twist them together. Once they're together, I'm going to put a little blob of solder on them to hold them real good and have a reliable connection. Easily and quickly done. That's our positive, the red lead. Now we're going to do the negative, our black lead. Same deal. Just like that. I like to use shrink tubing rather than electrical tape. You can use either, but shrink tubing just tends to have a nicer look and won't come undone like electrical tape does sometimes. Got a couple pieces of shrink tubing here that I'm going to be putting on here. You can use black vinyl electrical tape as well, does the same job. Get those on there, and I'm just going to use my heat gun to shrink those. Okay, that's done. So now we've got some nice long leads on this battery holder. The next thing we're going to do, on the old Bally boards that used a rechargeable battery, the board tries to recharge that battery while the game is running. You don't want the board to be charging standard AA batteries, alkaline batteries. It'll have bad effects, so you need to use what they call a blocking diode. The old Williams games that didn't use a rechargeable battery, they had a built-in blocking diode on the board, so you don't need to worry about adding this when you're doing it on a Williams board. What we've got here, this is a 1N4004 diode. It's a pretty standard rectifying diode. What we're going to do is we're going to hook this onto the positive lead coming from the battery holder that'll go to the board. You'll want to have the diode oriented so that the silver banded end of the diode is going towards the board. That acts as a blocker for the voltage that's coming from the board trying to get to the batteries. So we're going to just put that on the red lead from our battery holder, twist it on like we did the extension wire, give that a little bit of solder for a good reliable connection. And let's see, we're going to trim it up just a little bit, take some of the excess off here, bend it around like that, and use another piece of shrink tubing on here just for a nice, neat job. We'll pull that kind of down over the connection we made there and also over the body of the diode, so we just have the lead sticking out. Hit that with the heat gun real quick. Okay, so we've got positive and negative leads ready to go. We're going to trim this back just a little bit because we don't need that much for hooking to the board, and we're ready to hook it onto the board. Okay, here's our board again that we've already removed the original rechargeable battery from these 2 positions down here. This one on the left is positive. You can see it's marked with a positive symbol. The one on the right has no marking, but it connects directly to the ground trace that goes around the edge of the board. So that's your negative, that's your positive. We're going to hook the negative and positive leads of the battery holder to those respectively. Best to just get a little bit of solder going in some of these positions. There. And let's prime our wires with a little solder too, so they're ready to go. Everything will melt nicely once you get it on there. A little bit on the negative lead, a little bit on the positive lead with our diode there. Okay. Negative lead, we'll hook that over here to the old negative position where the battery used to connect. Let that dry, cool down, okay. Then our red lead with the diode end sticking out, we're going to put that right to that connection. Now both of these holes go all the way through the board, so you can stick your wire, your lead end a little bit through the board, make sure it's going through and getting good connection. That's really all there is to it. So you've got those hooked up. Here's your battery holder. You'll just want to mount that anywhere it's convenient for you in your back box. Use the little screws that come with it, as we sell those through our website. That'll hold it in place. Then you just add 3 AA batteries to this, and should be good to go. Let me show you how to check voltage once you get everything hooked up. Make sure you've done it right. Okay, here's 3 AA batteries. We're going to hook these in positions, get them loaded first. Just follow the diagram inside the battery holder to show which end goes where. And we've got those hooked up just fine. Taking your meter, setting it on the DC setting. What you want to do, put your negative lead on the negative wire where it connects to the board. Take your positive lead, check it on the positive, seeing 4.56 volts. That's perfectly normal. This battery voltage supplies this RAM chip right here. This needs to go no lower than 3.6 volts. If it does, at that point this memory will basically clear itself. Then you'll have problems. Need to reset your machine, put new batteries in, that kind of thing. To make sure you're getting battery power from your holder to that chip, place your negative lead on the negative position where we hook the battery holder. Take your positive lead, very carefully touch the very last pin, pin 22, on that RAM chip, U8, and I'm seeing 4.55 volts, about the exact same voltages I'm seeing down here, 4.55. So we are getting power to that RAM chip. It's active and doing its job to retain memory right now. That's all there is to it. Very simple process. That's how you check it when you're done. Hope that helps. If you have any questions, problems, feel free to email me. Thanks very much.